Okay, so number 3 on our outline is about broken eggs in a randomly selected carton of 1 dozen eggs. So first of all, let's explain what all this means. This would mean that the probability of me getting 0 broken eggs is 0.65 or 65%. Of 1 broken egg is 0.20 or 20%. Of 2 broken eggs is 0.10 or 10%. And the probability of getting 3 broken eggs is 4%, 0.04. Now the thing about any distribution is when you add them all up, they need to add up to p equals 1 or 100%. So I need to get 100% when I add these all up. So let's add these all up and see what this missing one is, this 4, because we don't know what it is. So it would be 65 plus 0.20 plus 0.10, 0.04, and that is equal to 65, 85, 95, 0.99. So what is this missing one? If it needs to add up to 1, it needs to be 0.01, which would be 1 minus 0.99 is 0.01, right? So this is 0.01. So there's a 1% chance that you have 4 cracked eggs, so that one is 0.01. Now how would I interpret the probability of y equals 1 is 0.20? So they're talking about this one right here. Probability of the 1 cracked egg is 20%. So that means there is a 20% probability my carton will have 1 cracked egg. It'll have exactly one cracked egg on it. So that's what the interpretation would be there, that there's a 20% probability my carton will have exactly 1 cracked egg. Okay, so for C, they say calculate the probability the carton contains at most 2 broken eggs. So think about the way they said that. I mean, if I said I had at most $20, that means I have $20 or less, right? So what would qualify here is everything 2 or less. This one, and this one. Any of those would match the description of what they're asking, so we can add those all together. So that is going to be 0.65 plus 0.20 plus 0.10. At most 2 broken eggs is 0.95 or 95%. Okay, what about at least 1 broken egg? So let's erase that. And so at least 1 would be 1 or more, right? So everything after 1. So this one, this one, this one, and this one. So the probability of at least 1 would be 0.20 plus 0.10 plus 0.04 plus 0.01. So that's 20, 30, 35, 0.35 or 35% would be my answer on that one. All right, for E, calculate the probability that the carton contains at least 2 broken eggs, at least 2. So at least 2 would be 2, 3, or 4, right? 2 or more. So 10 plus 4 plus 1. So the probability of at least 2 would be 0.1 plus 0.04 plus 0.01 or 0.15 total, or 15% chance that I'll have at least 2 broken eggs. So not that likely I'd have at least 2. So the next one is, what is the probability that the carton contains exactly 9 unbroken eggs? So what I need to know here is that exactly 9 unbroken is the same thing as saying, because if there's a dozen of them, if 9 of them are unbroken, that means that 3 are broken. So the probability of 3 broken eggs, and I look here, the probability of 3 broken eggs off the table is 0.04 or 4%. So 0.04 or 4%. All right, so for the next part, what is the expected number of broken eggs? To figure out the expected number, I would need to calculate the expected value for this table. And for the standard deviation, I need to calculate the standard deviation. I'm going to do that in Stapplet. Okay, so in Stapplet, what you want to go to put in a probability distribution like this is discrete random variables. And I'm going to select that one. And remember, there was 5 possibilities, 0, 1, 2, 3, or 4. So I'll put 5 of them. I'm going to put cracked eggs. Oopsie. GGS, cracked eggs. And you want to input your values and your probabilities. So if you need to, you can go ahead and pause the video now, and I'll give you some time to put those in. So I've put my values and my probabilities in. Make sure you put these in exactly like they are in the table that you made. And it looks like everything matches exactly with what we had. And I'm going to do begin analysis now. So let's do begin analysis. And there is our mean and our standard deviation. It is 0.56 and 0.898. Oops, it's not showing on there. Just a second, let me pull that up into the camera real quick. See, there's our mean right there, the 0.56, and the 0.898 is the standard deviation. So I'll go back, and the expected value is 0.56, and standard deviation is 0.898. The standard deviation is 0.898. So what those numbers mean basically is that on average there's about half a broken egg per carton. Because remember, it's an average, so it doesn't have to be, you know, normally there'll only be like 1 or 2 or like a set number, but on average there's 0.56, give or take like 0.9 in each direction. That tells you like how spread out the data is. So that is our number 3 on our outline.